Hey everyone, and welcome back for another deep dive. Today, we're going deep on something called anti-vibration shanks.
Anti-vibration shanks.
Yeah, sounds kind of specific, right?
It does.
But stick with me, trust me on this one. It's way more interesting than you might think. We're diving into this technical document all about a tool system called Multimaster.
The Multimaster, okay.
So these tools, they're already pretty cool because they have all these swappable heads, makes them super versatile.
Well, I see, like a Swiss Army knife, but for machining.
Exactly. But the real star of the show today is the shank.
It's shank.
The shank, basically the handle.
Oh, okay, got it.
So imagine you're a surgeon.
Right.
And you have to, perform surgery inside a tiny blood vessel.
Yeah.
Super delicate stuff.
High stakes.
Exactly. But now, imagine your tools are shaking like crazy. That's basically the problem these new shanks are tackling.
So it's all about precision, keeping things steady.
Precisely. That's the key takeaway here. Now, I get that long tools vibrate. That just makes sense.
Right.
But I'm curious, why is that, says CH, a big deal when it comes to machining specifically?
Well, think about it. Machining is all about precision, right? It's about getting those measurements exactly right.
Microscopic tolerances sometimes.
Exactly. And even the slightest vibration can throw everything off. Suddenly, your measurements are inaccurate, surfaces are uneven, you could even damage the tool itself.
Oh, I see. Yeah, if your drill bit is wobbling all over, that's not good.
Not good at all. It's kind of like, trying to write your name neatly on a bumpy bus. Just about impossible.
Okay, I'm picturing that bumpy bus. So,
yeah.
How do these new shanks smooth out the ride, so to speak? The document, it mentions they're made from carbide.
Carbide, tough stuff.
Super tough. And it also mentions something called an assembled structure. Now, what does that even mean? Is it not just like a solid chunk of metal?
You got it. It's not just a simple hunk of carbide. It's quite ingenious, really. They've created a shank with multiple parts, and they're all carefully arranged to absorb vibrations. It's like
a shock absorber almost.
Exactly, a shock absorber for a tiny little machining tool. And using carbide is key here. I mean, it's super strong, right? Which is essential for a tool that's going to be under a lot of stress.
Right. Got to be durable.
But it also has this unique ability to dampen vibrations.
Wait, so carbide itself helps absorb the vibrations. Is that a common thing in tools? What makes this approach different?
Not as common as you might think. Usually you'd have to add separate dampening materials.
Like rubber or something?
Yeah, something like that. But those can be bulky and sometimes less effective.
Makes sense.
But here, with these new shanks, they've managed to build that dampening right into the shank itself just by using the properties of carbide.
Wow, so they're basically using the material itself to do double duty, huh?
Exactly. It's a really elegant solution, really impressive engineering. That's really clever. I wouldn't have thought of that. So it's almost like they took, a jackhammer and turned it into a scalpel.
That's a great analogy. It's all about getting that perfect balance of strength and precision.
And I noticed they come in different sizes, too. The document, it talks about all these different length to diameter ratios.
Right. Different ratios for different needs.
So I'm guessing that means these shanks can reach even further into tight spaces.
Exactly. They've designed them with all sorts of reach capabilities in mind. You can get just the right amount of overhang, depending on the specific job.
So, you could work on a massive piece of industrial equipment or something tiny and delicate, like an electronic component, and you'd still have the right shank for the job.
Exactly. Versatility is the name of the game.
The document also kept mentioning something called unstable machining conditions. Now, what exactly does that mean? And why is vibration control extra important in those situations?
Well, think back to that bumpy bus, right?
Oh, yeah, back to the bus. Unstable machining conditions, they're kind of like that. It's all these external factors that can create vibrations. Could be the material you're working with.
Oh, so some materials are just more prone to vibration.
Exactly. Or it could be the speed of the machine. Even the temperature of the environment can play a role. But the point is, when you've got all these factors at play, having a tool that can counteract those vibrations, that's absolutely essential for maintaining accuracy.
So basically, these shanks are taking that bumpy bus ride and turning it into a smooth train ride, even when things are chaotic around it.
Precisely. It's a real game changer, especially in industries where precision is everything.
And like the document said, this innovation could really push the whole Multimaster system forward. It's not just about, making a better shank. It's about what that shank allows you to do.
Exactly. It's about opening doors to new possibilities.
And it kind of makes you wonder, if vibration control is this important in machining, Where else could we apply this? Like, could we make steadier surgical tools? More stable construction equipment? What about, I don't know, tools for space exploration?
Now, those are some exciting possibilities.
Definitely food for thought there. So, just to recap for everyone, we've got these carbide shanks with a super clever built-in vibration dampening system. Not only does it make the machining process smoother and more precise, it also opens up this whole world of possibilities.
Pretty impressive for something so seemingly small, huh?
It really is. All right, folks, keep those brains buzzing, and we'll see you on the next deep dive.